Throughout Earth's long and turbulent climate history, there's one period that continues to mystify scientists even today, the Younger Dryas. Around 12,900 years ago, just as humans were stepping into a new era and massive creatures like woolly mammoths and saber-toothed cats still roamed the landscape, something changed. Suddenly and dramatically, global temperatures plummeted. Freezing winds swept across continents. Ice sheets surged back over the land. And here's the wild part. This transformation happened in just a few decades, a blink of an eye in geologic time. Then, just over 1,000 years later, it ended just as suddenly. So what caused this deep freeze? How did it impact human communities? And was it really as world-changing as we think? Let's start with the name. Younger Dryas comes from a hardy little tundra flower called Dryas octopetala. This plant thrives in cold, alpine environments. So, when scientists find its pollen in high concentrations in sediment layers, it tells them the climate was freezing. The younger part refers to this being the most recent of 3 such cold periods that interrupted the gradual warming after the last ice age. Thanks to ice core data from Greenland, we know the Younger Dryas began around 12,900 years ago and ended somewhere between 11,700 and 11,550 years ago. So the cold snap lasted about 1,150 to 1,300 years. But here's where things get weird. It didn't hit the entire world at once. In parts of northern Europe, especially around latitudes 54 to 56 degrees north, the cooling kicked in earlier, maybe even as far back as 13,100 years ago. But farther north, the drop didn't happen until centuries later. The timeline becomes even more staggered as you move east. In Japan, for example, lake sediments suggest the temperature drop didn't start until 12,300 years ago, some 600 years after Europe started freezing. China shows a similar delay of 200 to 300 years. And in the Philippines, evidence suggests the cooling didn't arrive for 500 to 600 years, and even then, it was relatively mild. This reveals something crucial. The Younger Dryas didn't affect the planet equally. The North Atlantic region, Europe, North America, and parts of the Arctic got hit the hardest. In Europe, the climate shifted shockingly fast. Some areas saw temperatures drop in less than a decade. For anyone living through it, the change would have been impossible to miss. In Greenland, the average temperature fell by anywhere from 4 to 10 degrees Celsius. In the British Isles, fossilized beetles suggest winters may have reached a chilling -23 degrees Celsius. But it wasn't all endless winter. Interestingly, short but surprisingly warm summers still occurred, especially in southern regions like the Iberian Peninsula. There, between 12,600 and 12,000 years ago, the climate remained fairly warm and dry. It wasn't until closer to 12,000 to 11,700 years ago that things became wetter and colder. In the Middle East, the effects were milder. Some regions were already drying and cooling even before the Younger Dryas began, and that pattern continued afterward. North America, especially the Northeast and Central Plains, was another region that felt the full force of this climatic shock. Temperatures fell around 7.5 degrees Celsius. Forests gave way to tundra. Precipitation dropped. The massive Laurentide ice sheet, which had been slowly shrinking, began growing again. Rivers changed course. The Rocky Mountains saw more snow and glacial expansion, though they weren't as cold as the east. Areas closer to the Gulf of Mexico were less affected, and interestingly, the Caribbean actually warmed slightly. Now, let's take a look at the southern hemisphere, where the story flips. Most places weren't affected much at all. In fact, some got warmer. In South America, glaciers in Peru and Bolivia retreated. North Africa, which was surprisingly lush at the time, didn't seem to change much. Western tropical Africa actually warmed a bit, while Eastern Africa cooled slightly. Australia appears to have become warmer and wetter. Oceania, overall, barely registered any impact. Of course, when you have glaciers expanding across the northern hemisphere, sea levels drop. During the Younger Dryas, global sea levels fell between 20 and 40 meters, around 2 to 4 centimeters per year. That might not sound like much, but over 1,000 years, that's enough to redraw coastlines. So we've seen the effects, but what caused it? The leading theory points to a disruption in the Atlantic Ocean's heat engine, what scientists call the Atlantic Meridional Overturning Circulation, or AMOC. This system acts like a conveyor belt, carrying warm water from the tropics northward and cold water back south. But when massive amounts of freshwater from melting glaciers, especially from ancient lake Agassiz, poured into the North Atlantic, it messed up the balance. Cold freshwater is lighter than salty ocean water, so it stopped sinking and stalled the circulation. That likely triggered the rapid cooling. And here's what's really telling: while the northern hemisphere froze, the southern hemisphere warmed slightly. That kind of imbalance makes sense if the ocean currents were disrupted and heat stopped flowing north. There are other ideas too, like the Younger Dryas impact hypothesis, which claims a comet or asteroid exploded in the atmosphere and triggered global fires and a kind of impact winter. We'll get into that theory soon, but most scientists still favor the ocean current disruption theory because it fits both the timeline and the geography of what we see in the fossil and ice core record. Now that we've seen how the world changed during the Younger Dryas, the question becomes: how exactly did the Atlantic's great heat conveyor break down so suddenly? What really caused the ocean currents to falter, and how do we even know that happened? Let's zoom in on a prehistoric giant, Lake Agassiz. This was one of the largest freshwater lakes to ever exist, formed by the melting of the Laurentide ice sheet in what is now central North America. At its peak, Lake Agassiz covered an area larger than all of the modern Great Lakes combined. And it was deep, trapped behind walls of ice, holding back more freshwater than the Mississippi River carries in a decade. As the ice sheet continued to melt, pressure built up. Then, sometime around 12,900 years ago, it happened. A massive outburst flood, millions, possibly even trillions, of gallons of freshwater surged into the North Atlantic, either through the St. Lawrence River Valley or westward into the Arctic. Either way, this sudden influx of cold, fresh water disrupted the salinity and density of the Atlantic Ocean's surface, shutting down the AMOC, the great oceanic engine that warms Europe and moderates global climate. This idea, first proposed in the 1980s and 1990s, still stands as the most accepted explanation for the Younger Dryas. And there's solid evidence backing it up. Ocean sediment cores show a sharp drop in deep ocean circulation during this time. Ice cores from Greenland confirm a rapid cooling. And isotopic analysis of foraminifera, tiny marine organisms, supports the idea of changing salinity in the North Atlantic. But it's not the only theory. Some researchers believe the Earth may have been struck, or nearly struck, by an extraterrestrial object. Known as the Younger Dryas impact hypothesis, this theory suggests that a comet or asteroid either exploded in the atmosphere or struck an ice sheet, triggering massive fires, rapid climate disruption, and a global cooling effect. Proponents point to a layer of charcoal and soot found in sediment layers across North America and Europe, rich in platinum and nanodiamonds, materials often associated with extraterrestrial impacts. They argue that this impact could have simultaneously caused the mass extinction of megafauna, the collapse of the Clovis culture in North America, and the onset of the Younger Dryas cold period. Intriguing stuff, but the theory is controversial. Critics say the evidence isn't consistent enough, and many of the materials cited, like nanodiamonds, can also be formed through other processes, like intense wildfires. Still, the impact hypothesis continues to spark debate. If it's true, it would mean the last ice age ended not with a whimper but with a bang. A cosmic catastrophe that reset the clock for both climate and culture. But whether it was a cosmic explosion or the slow pressure of glacial melt, the results were the same. The Atlantic circulation was thrown off balance. Northern latitudes froze, southern regions warmed slightly, and human civilizations, still fragile and scattered, were forced to adapt or disappear. Let's not forget, this wasn't a time of cities or nations. We're talking about small bands of hunter-gatherers, slowly experimenting with agriculture, clustered around rivers and lakes. And then, climate shock. The world they knew began to vanish. Forests receded, waterways dried up or froze. Game animals migrated or went extinct. It's likely that many communities were forced to move, while others simply didn't survive. But some did more than survive, they innovated. As strange as it sounds, the Younger Dryas may have played a key role in launching the very first civilizations. In fact, some archaeologists argue that without this sudden climate disruption, we might not have developed agriculture, or at least not as quickly as we did. Let's travel to the Fertile Crescent, a region stretching from modern-day Israel and Palestine through Syria, Lebanon, and into parts of Turkey and Iraq. Around 13,000 years ago, just before the Younger Dryas, this region was home to the Natufians, a culture of semi-sedentary hunter-gatherers. These people were different. They built permanent stone houses, stored grains, and even used sickles to harvest wild cereals like barley and wheat. In a sense, they were almost farmers, but not quite. Then the climate shifted. With the onset of the Younger Dryas, the region became colder and drier. Rainfall decreased, wild plants grew more sparsely, game animals moved on, and the Natufians were left in a tough spot. The environment could no longer support their previous lifestyle. What did they do? Well, here's where human ingenuity comes in. Facing environmental stress, the Natufians didn't give up, they adapted. Some groups abandoned their villages and returned to nomadic life. But others began actively cultivating the wild grains they had once merely gathered. They started selecting and planting seeds from the hardiest plants. Over time, this led to the domestication of key crops like emmer wheat, einkorn, and barley. In short, agriculture was born not during a time of abundance, but during a climate crisis. This shift wasn't just about plants. People began to settle more permanently. They built new kinds of structures. They stored food in pits and granaries. Villages grew, social hierarchies began to form, rituals developed, the foundations of civilization were being laid. And then, something even more astonishing happened. At the very end of the Younger Dryas, around 11,600 years ago, people in southeastern Turkey began constructing Göbekli Tepe, the oldest known monumental religious site on Earth. Long before writing, before pottery, even before domesticated animals, they were carving massive T-shaped limestone pillars, weighing up to 20 tons, and arranging them in circles. Some of the stones were engraved with images of lions, scorpions, snakes, and vultures, symbols whose meanings we still don't fully understand. Why would small groups of foragers build something so grand, so complex, and so deeply spiritual? Some scholars suggest Göbekli Tepe was a response to the instability of the Younger Dryas. As traditional food sources became unpredictable, people may have turned to ritual and religion to bring back order. These early temples could have been places of gathering, of shared belief, a way to strengthen bonds between communities during hard times. And here's a twist. Göbekli Tepe seems to have come before large-scale farming. This challenges the conventional view that agriculture led to religion and monuments. Instead, maybe it was the need to gather and worship that encouraged people to stay put, and that led to farming. So, in a strange way, the Younger Dryas may have triggered the first great leap in human culture. What began as a climate disaster ended up sparking innovations in food, belief, and community. It's a powerful reminder that crisis doesn't always mean collapse. Sometimes, it creates the conditions for something entirely new. While humans were adapting to the harsh shifts of the Younger Dryas, changing their diets, building temples, and planting seeds, something far more tragic was playing out across the rest of the world. One by one, the giants of the Ice Age were disappearing. Woolly mammoths, saber-toothed cats, giant ground sloths, mastodons, short-faced bears, these magnificent creatures, which had roamed the earth for tens of thousands of years, vanished within a geologically brief moment. By the end of the Younger Dryas, nearly 75% of the world's large mammal species were extinct. In North America alone, at least 35 genera of megafauna disappeared. So what happened? The two leading suspects are climate change and humans, and most experts agree it was probably a deadly combination of both. Let's start with climate. The end of the last ice age brought enormous environmental changes. Temperatures rose, glaciers retreated, and ecosystems shifted dramatically. The great grasslands that once supported herds of mammoths and bison gave way to forests. Water sources dried up. Food chains were disrupted. Many of these megafauna species had adapted to the cold, stable conditions of the Ice Age. When those conditions disappeared, so did their niches. But here's the catch: similar climate fluctuations had occurred in the past, and those animals survived. Why was this time different? That's where humans come in. By the time of the Younger Dryas, Homo sapiens had spread to nearly every continent. In North America, the Clovis people had perfected the art of hunting with fluted stone spearpoints. In South America, evidence shows early human settlements in regions once teeming with giant sloths and toxodons. In Australia, people had already been hunting giant marsupials and thunderbirds for thousands of years. Wherever humans arrived, megafauna began to vanish. Some call it the blitzkrieg hypothesis, a fast, efficient overhunting that drove species to extinction in just a few centuries. Others suggest a slower, more complex process involving habitat disruption, competition, and stress from multiple angles. But the outcome was the same: extinction. And it wasn't just animals that were lost. With them went entire ways of life. Cultures that had depended on mammoth hunts or large herd migrations were suddenly cut off from their primary food sources. Tools had to change, diets had to shift. It's no wonder we see bursts of innovation and migration during this period. People were reinventing their place in a changing world. What's haunting about the megafauna extinction is how global it was. Mammoths disappeared from Europe, Asia, and North America almost simultaneously. Giant kangaroos vanished from Australia. Glyptodons, those massive, armored relatives of armadillos, faded from South America. It was like a curtain closing on an entire chapter of natural history. But there were exceptions. On Wrangel Island, a remote Arctic outpost off the coast of Siberia, a small population of mammoths managed to survive until around 4,000 years ago, contemporaries of the Egyptian pyramids. Isolated and sheltered, they escaped the mass extinction for a few thousand extra years, a lonely remnant of a vanished world. Their survival, however brief, reminds us how fragile, and how strange, this moment in history truly was. Because while the great beasts fell, we endured. Somehow, in the chaos of a planet transforming, humans didn't just survive, we thrived. We adapted, invented, organized, and dreamed. And in doing so, we began shaping the Earth in ways no species ever had before. Around 11,700 years ago, the Earth finally exhaled. The wild swings of the Ice Age ended, the freezing chaos of the younger Dryas faded, and in its place came a new climate era, the Holocene. This was not just another warming period. The Holocene was something else entirely. For the first time in hundreds of thousands of years, Earth's climate became remarkably stable. Temperatures evened out, rainfall patterns settled, the glaciers stopped surging and retreating. Sea levels rose to their modern heights and then leveled off. It was as if the planet had hit the pause button, after a very long, turbulent movie. And that calm changed everything. Because finally, humans had the predictability they needed to build something permanent. Across the world, this new chapter unfolded in strikingly similar ways. In the Middle East, the descendants of Natufian foragers became full-time farmers, building larger villages and beginning to domesticate sheep, goats, and cattle. In China's Yellow River Valley, early communities started planting millet, while those near the Yangtze cultivated rice. In Mesoamerica, ancient peoples slowly began domesticating squash, maize, and beans. In the Andes, they tamed the potato. These weren't fast changes. Agriculture took thousands of years to spread and refine. But the possibility was now there. Nature was no longer a wild card. You could count on the seasons. You could plan a harvest. You could raise children in the same spot you grew up. Stability, it turns out, is the real foundation of civilization. With regular harvests came food surpluses. With surpluses came population growth, more mouths, yes, but also more minds. More ideas. People began specializing, some planted, some fished, some carved, some counted. Societies became more complex, and soon, the first cities began to emerge. Think of Çatalhöyük in modern-day Turkey, a dense settlement of mud-brick houses with shared walls and no streets, where people walked across rooftops and buried their dead beneath their homes. Or Jericho, with its massive stone walls and central tower, already standing strong by 10,000 years ago. These early towns weren't just about shelter. They were about meaning. People painted murals, traded goods, built shrines. They stored food in communal granaries. They created rules, roles, and rituals. The seeds of politics, religion, economy, and identity were all being sown here, quietly, patiently, brick by sunbaked brick. And none of it would have been possible without the Holocene. That long stretch of climate stability gave rise to everything we think of as human: art, law, writing, empires, money, machines. It was the calm that let our stormy species grow roots. So when we look at the Holocene, we're not just seeing a geological epoch, we're seeing our window. A moment when the Earth gave us the chance to rise. But here's the sobering thought: that window may not stay open forever. Today, our industrial civilization is changing the climate faster than it has changed in tens of thousands of years. In just a few centuries, we've begun to alter the very stability that made civilization possible in the first place. The Holocene might be ending, not by natural forces, but by our own hands. And that raises a question we'll return to later. Can we survive the next big shift as gracefully as we survived the last? Once the Earth settled into the Holocene's stable rhythm, people all over the world began crafting their own responses to this new chapter. What's fascinating is that while the idea of civilization might conjure images of pyramids or palaces, early human complexity didn't follow a single path. Instead, it emerged in many places at once, shaped by local rivers, plants, animals, and dreams. Let's begin with the Nile. In northeastern Africa, the Nile River began flowing in a more consistent, predictable pattern after the end of the Ice Age. This made the surrounding land fertile and rich, a long green ribbon in the middle of vast desert. Small communities settled along its banks, fishing, planting, and eventually building small hamlets. By around 9,000 years ago, people were cultivating wheat and barley, crops originally from the Levant. But Egypt wasn't just borrowing ideas. It developed its own distinct agricultural systems and burial traditions that would, in time, shape one of the world's most iconic civilizations. Now shift east, to the Indus Valley. Here, in what is today Pakistan and northwest India, people were living in small farming villages along rivers like the Ravi and the Ghaggar Hakra as early as 7000 BCE. These early farmers cultivated barley and raised zebu cattle. Over time, their settlements grew, evolving into large urban centers like Harappa and Mohenjo-Daro. What made the Indus unique was its attention to infrastructure, massive granaries, public baths, advanced drainage systems. No kings, no giant temples, no obvious signs of warfare. Just order, water, and an enduring mystery. Further east, in the lush basins of the Yangtze and Yellow Rivers, Chinese communities were pioneering their own agricultural revolutions. They domesticated millet in the north and rice in the south, each region shaping a different kind of society. By around 5000 BCE, villages were growing in size, and evidence of social hierarchies began to appear: cemeteries with rich grave goods, pottery kilns, and jade carvings. Meanwhile, on the other side of the planet, something astonishing was happening in the Americas. In Mesoamerica, long before the Aztecs or Maya, people had begun domesticating squash and chili peppers. Maize, the crop that would later feed empires, was first bred from a wild grass called teosinte in southern Mexico. This wasn't a quick process. It took thousands of years of selective planting to turn teosinte's hard little kernels into the soft, golden maize we recognize today. And yet, that slow work laid the foundation for civilizations like the Olmec, Maya, and Zapotec. In South America, particularly along the coasts and river valleys of Peru, early communities mixed fishing with farming. They built platform mounds and experimented with cotton, potatoes, and quinoa. These people didn't leave behind giant stone monuments, but they created sophisticated irrigation systems and formed complex trade networks that stretched from the Andes to the Pacific. And in Amazonia, far from the image of untouched wilderness, humans were transforming the landscape in subtle, powerful ways. They planted orchards, sculpted the soil into what's now known as terra preta, and engineered raised fields that resisted floods. These weren't small-scale efforts, they were intentional, large-scale ecological designs. The forest itself, in many places, is a kind of living archaeological site. Each of these regions, Africa, South Asia, East Asia, the Americas, was responding to the same planetary shift, but in its own way. Some built in stone, others in earth. Some formed priesthoods, others village councils. But all were experimenting with how to live, grow, and endure. That's the real story of early civilization. It wasn't a single invention or one flash of genius. It was 1,000 local answers to the same global question. Now that the world is calm, what kind of world will we make? And the answers they came up with would shape human life for millennia to come. By around 6,000 years ago, in scattered places across the globe, a new kind of human settlement began to emerge: cities. Not just clusters of huts or seasonal camps, but dense, permanent spaces filled with hundreds or thousands of people. Places where life became more organized, more interdependent, and more unequal. Take Uruk, in ancient Mesopotamia. By 3500 BCE, this Sumerian city may have held 40,000 people, making it one of the largest settlements in the world at the time. Its temples loomed over the flat plains, its scribes were inventing writing to track goods and taxes, and its canals and workshops bustled with activity. This wasn't just a big village, it was a state in miniature. Uruk didn't grow in isolation. It was part of a broader pattern, one where increasing populations, agricultural surpluses, and social stratification all converged to create something radically new. These cities became engines of innovation. In Mesopotamia, they gave rise to cuneiform script, wheeled carts, and formal legal codes. In Egypt, they built the organizational machinery that would raise pyramids. In the Indus Valley, they perfected urban sanitation before most of the world knew what that meant. But here's what's important: not everyone went down that path. In fact, most human societies didn't. Across Europe, countless Neolithic communities lived for thousands of years without forming cities or states. They built megalithic monuments, like the Long Barrows of Britain or the Stone Circles of Brittany. They farmed, feasted, traded, and when one village declined, another often rose to take its place. There were chiefs, yes, and spiritual leaders. But not kings, not palaces, not armies. In the Americas too, large parts of the continent remained outside the orbit of urban life for millennia. People there built earthworks, like the vast ridged fields and ceremonial mounds of the eastern woodlands. Some societies, like the Hopewell culture, linked far-flung regions through networks of trade and ritual. Others, like those in the Amazon or the high Andes, developed intricate systems of landscape management and agriculture, but with fluid or seasonal leadership, not centralized rule. And even in places where cities did emerge, they didn't always last. Look at Çatalhöyük, the dense Neolithic settlement in Turkey we mentioned earlier. It thrived for over 1,000 years, but eventually faded. It left no temples, no royal tombs. Its memory lives on in its walls, its murals, its burials beneath the hearth. But not in conquest or empire. All of this reminds us of a crucial truth: civilization isn't one thing. It's not a pyramid on a postcard or a king's name chiseled into stone. It's not even cities or writing or bronze. Civilization is a way of organizing life, and there have always been many ways to do it. Some paths led to bureaucracies and dynasties. Others led to confederacies of tribes, rotating leadership, or decentralized networks of ritual and exchange. And some societies chose not to centralize at all. They saw hierarchy not as progress, but as something to be resisted. That's not a failure of development, that's a choice. A philosophy, a different way of being human. So while the great cities of the Bronze Age would soon take center stage, with their armies and gods and glittering treasures, it's worth remembering that they were never the only show in town. Beneath and beyond the capitals, other worlds were flourishing, quieter but no less meaningful. Worlds built on kinship, on ecology, on memory and myth. And the tension between these two visions, centralized power versus communal life, has never gone away. It still shapes our choices today. By around 3000 BCE, something profound began to shift in human society, not just in how we lived, but in how we remembered. For tens of thousands of years, stories had been passed down through song, through myth, through the rhythmic repetition of elders' voices by the fire. Knowledge was held in memory, in landscape, in ritual. It was living, flexible, always evolving. But now, in several places across the world, humans began to write. In Mesopotamia, scribes etched cuneiform symbols into wet clay tablets, first to track grain, sheep, and taxes. Then gods, kings, laws, and dreams. In Egypt, they wrote with reed pens on papyrus scrolls, blending art with administration in the flowing curves of hieroglyphics. In China, early characters were inscribed on oracle bones, divining the future and preserving the past. This was the dawn of history, not just events that happened, but events that were recorded. Names, dates, causes, victories. It's easy to be swept up in these ancient chronicles: the rise of kings, the building of monuments, the declarations of empires. And they are extraordinary. Think of the Epic of Gilgamesh, written more than 4,000 years ago, already asking the deepest human questions about mortality, friendship, and the search for meaning. But written history is also selective. It remembers power. It records what the powerful want remembered. The voices of the many, farmers, mothers, wanderers, weavers, children, are often missing from the tablets and scrolls. Their lives leave quieter traces. In garbage pits, in footpaths worn into stone, in broken pots and pollen layers and the shape of old hearths. That's where archaeology steps in, helping us reconstruct the full spectrum of human life, not just the rulers, but the ruled. Not just the battles, but the kitchens and gardens and burial grounds. And what emerges is a picture not of a single human story, but of many simultaneous experiments, some successful, some short-lived, all rich with intention. By 2000 BCE, large states had arisen in Egypt, Mesopotamia, the Indus Valley, and northern China. But these were still exceptions. Across most of the world, humans continued to live in small communities, in seasonal camps, in forest clearings, on riverbanks and mountaintops. They fished, hunted, farmed, traded, told stories, raised children, and buried their dead with care. Some lived under kings, others in collectives. Some had gods with names and temples. Others had spirits in trees and rivers, in wind and flame. And all of them, every single one, was part of the great human experiment. How to live together, how to shape the world without destroying it, how to remember what matters. We often look back and try to find beginnings, the first cities, the first writing, the first laws. But really, human history is less about clear starting points and more about layers, interwoven, overlapping, each one shaped by what came before and what might come next. As we bring this journey to a close, it's worth pausing to reflect on just how much was happening across the world 10,000 years ago, and how much of it still echoes through our lives today. By this time, humans were no longer just surviving. We were thriving. We had moved beyond merely reacting to the environment. We had started reshaping it. In multiple regions, we domesticated plants and animals, altering ecosystems in ways that would never return to their original state. We made homes, symbols, and music. We buried our dead with intention. We dreamed up gods, ancestors, and ideas of order. We were, in short, becoming the world's dominant species, not just in number, but in impact. And yet for all our brilliance, we remained deeply tied to the rhythms of the natural world. The rising of rivers, the return of rains, the pulse of the seasons. The story of early human civilization is not one of steady progress, but of diverse choices, countless adaptations, and constant dialogue with the land and one another. And perhaps that's the most important lesson, that there has never been only one way to be human. There have always been many.